Okay, this is Michelle Pengel and Frank Pishva's General Chemistry 1. This is lab number 1, and the particular lab is in regards to measurements. I will be doing specifically data table 2, which is on measurement of temperature. So I set up a data table to record my findings, and the things that we'll be looking for in this experiment are the temperature in degrees Celsius of hot tap water, boiling water after 5 minutes, cold tap water, and ice water after 5 minutes. So the first thing we need to do is gather all of our supplies, which I've done. I'm just going to list them off right here. First is the 100 milliliter glass beaker. Put that down here. The second thing is a cup, a plastic drinking cup. Matches or a lighter to light the wick. I had one, I don't know what happened to it. I got it right here. Then the third thing that we need is a burner stand, which we also have right here. Burner fuel and a glass thermometer. So we have all of those items set up right here. And then we've also placed this burner stand and the wick on top of another plate just to be safe. And as I'm reminded of safety, I also have my goggles and my gloves. So I'm going to put those on now so that we can start our measurements. Okay, so the first thing that we're going to do is look at the calibration marks on the thermometer, which I had done earlier. And it appears that they are to the tenths and place, and so that therefore would be 2 significant figures, I believe. I finished getting my gloves on. The next thing is that we turn on the tap water to hot, which we've already done, and we let the excuse me. We let the hot tap water run for 5 minutes, or I'm sorry, 15 seconds. And we also transfer the hot tap water from this cup into this 100 milliliter glass beaker, and we transferred approximately 75 milliliters per the request of the slab. So now we're going to measure that temperature. So it also says to note that we don't want when measuring the temperatures, place the thermometer into the water so that the silver bulb is fully submerged, but not touching any sides of the glass beaker. And the measurement will be complete when the thermometer remains the same temperature without changing. So we're going to do that right now. We're going to watch it rise. So it looks like it's approximately 30.1 degrees Celsius. So we need to record our findings. I'm going to place this on paper so that it doesn't break. And when after we have, how much time is left? 1 minute? Okay, so after we have gathered all the data for the hot tap water, boiling water, cold tap water, ice water, etc., we're going to convert them from Celsius, then Celsius to Fahrenheit, and then Fahrenheit to Kelvin. So 30.1 degrees Celsius will be calculated to whatever the equivalent is in Fahrenheit and whatever it is in Kelvin. Okay. So the next thing that we're going to do is place the beaker of water. This is the beaker, 100 milliliter beaker. Oh, I didn't put my goggles on. Onto the wire rack, gauze burner stand, and put on the safety glasses, which I've already done. And we're gonna take this cap off of the burner fuel, is that it? Okay, just to summarize, all we did so far was just a simple start of the data, table 2, and we recorded our measurement, which is 30.1 degrees Celsius. So apparently our tap water at our house is not actually that hot, due to it being similar to the regular tap water temperature. So anyways, that's it. Again, my name is Michelle Pangel for Frank Pishva's general chemistry, and I will record the rest of the data and summarize it in my lab report. Thank you.